Hello everyone. In this session, we'll discuss about this shear force and bending moment. So first we have to know what is shear force and what is bending moment, definitions, and how the shearing action will be developed in a beam. So for that, let us see if suppose this is a rectangular beam. On this rectangular beam, this is one end and this is another end. The beam is supported with the two ends, and on this beam, if suppose I am applying a point load W, and here the length of the beam is L. So here, due to this external force acting on the beam, sometimes the beam will split into two parts due to this more external load. So if the beam will split into two parts, that is generally called as shear. So the splitting action of the beam due to this external force, that is called as shearing action, that is known as shear force. And the bending moment is nothing but if suppose in this is external load at A and at B. Sometimes due to this external loads, the beam will not split. The beam will deflect or bend. So the bending action is like this. At the end points, see, and the beam will be bend or yield due to this external force. This portion is the deflection of the beam. So due to this external force W, the beam will yield or bend like this. So due to this external force, the beam will be bend, that is called as bending moment. So here let us see the definition of shear force and the definition of bending moment, and what is shear force diagram and what is bending moment diagram. So the definition of shear force is nothing but if suppose the beam will split into two parts here, then this is the cutting section. In this diagram you can see this is the cutting section. Here one force at the end portion, this is upward force and this is the downward force. Here also some upward forces, some downward forces are there. So algebraic sum of the forces of a beam to the right or left of the section. This is the right side of the section and this is the left side of the section. So algebraic sum of these vertical forces acting in a section of the beam to the right or left of the section, that is called as shear force. So here it is totally depends upon the force. So the shear force units are newtons or kilonewtons. And coming to the shear force diagram definition, here the shear force changes from along the length. So the variation of the shear force along the length of the beam is called as shear force diagram. Coming to the bending moment. So here we know that already the beam will be bend or yield due to some external forces acting on the beam. Suppose this is a simply supported beam, like simply supported beam. In this case, the deflection will be that the bending will be like this. If suppose in this figure you can see this is a cantilever beam, because here one end is fixed and other end is free. If suppose the point load is acting at the free end, then the yielding will be like this in cantilever beam. This is the vertical beam, but due to some external force, the beam will be bent like this. So here what is bending moment is nothing but algebraic sum of the moments along the forces acting to the right or left of the section. Here the bending moment is nothing but force into perpendicular distance. How much of force is acting and how much of deflection will be there at a distance of So here that force can be measured in terms of newtons and distance can be measured in terms of meters. So the units of bending moment is Newton meter. Similarly, in sometimes the Newton mm or kilonewton meter or kilonewton mm. These are the units of bending moment. And now see the bending moment diagram. Here the bending moment is also changes from the point to point in a load to load in a beam. So the variation of the bending moment along the length of the beam, that is called as bending moment diagram. So here how to draw the shear force diagram and bending moment diagram means, before that we have to know the sign convention of the shear force and bending moment diagram. Let us see the sign convention of the shear force and bending moment diagram. Yes, now let us see the sign convention for shear force and bending moment. So if suppose this is a beam, this is x-axis section, this is the right side of the section and this is left side of the section. On the right side at the end we have one force and right side downward one force and left side downward and left side upward. Now here the force is passing through the along this x-axis section. Then see the sign convention. If suppose this is the right side upward, this is x-axis section. So this force is moving in this direction to this x-axis section. Means what is this direction? Anti-clockwise direction. So anti-clockwise direction will always negative. Means here the right side upward force is negative. For this you have to remember the word run. Here right side upward negative. Similarly, right side downward. For this, from this force to x-axis section, this force is moving like this. So this direction is clockwise. So right side downward is positive. Now coming to the left side, this left side downward is moving in this direction. So what is this direction here? Anti-clockwise. So this is negative. And coming to this one, here this is moving in this direction. Left side upward. This is clockwise. So here we'll get the sign convention as positive. Now let us see in this first figure. The left side upward is clockwise and right side downward is clockwise. So those two are under positive shear force. Now see this first figure. This is x-axis section and right side downward is positive. Similarly, left side upward is also positive. This shear force is positive shear force. Coming to the negative shear force. In this figure, the right side upward is negative and left side downward is also anti-clockwise. So we'll get negative shear force. Now see in this figure, this is the x-axis section. The right side upward is negative and left side downward is negative. So these two are the negative shear force. So you have to remember this one word only, run. Right side upward will be always negative. Then right side downward will be positive. Then left side downward is negative and left side upward is positive. Okay, this is shear force sign convention. Now coming to the bending moment. So here in coming to the bending moment, the beam will be deflected. So in the deflection form, in some cases, here due to this external load, the beam will be deflected. So this is the here. This is clockwise moment and this is anti-clockwise moment. This type of bending is called as positive bending moment. In some cases, if suppose the cantilever will be there, for that cantilever the beam will be bent like this. So here the bending is in this direction. So this type of bending is negative bending. For this you have to remember only the smile is always positive and this is always negative. So this type of bending moment will be always positive bending moment and this is always negative bending moment. So this is the sign convention for the shear force and bending moment. Thank you.